Hello! This is a video of the Bubble Popper activity in which I, Pippin Bar, will attempt to do the activity by following through the steps and talking about what I'm doing. No, apparently. Okay, that is what I'm going to do though, despite what this machine learning algorithm thinks. So let us begin with the instructions. So the idea behind this activity is largely to get some comfort with using ML5.js. And in particular, we're going to use the hand pose feature, which is the hand recognition stuff. And really that comes down to setting up the basic framework of recognizing hands and then dealing with the data that comes out of it and turning it into something interactive and interesting in an actual program. So the fairly small task that we're going to give ourselves is we're going to use hand tracking. We're going to find the user's index finger and we're going to make that into a pin. So there's going to be a pin that kind of represents the user's index finger on the canvas. And there's going to be a bubble, aka a circle, that's going to float upwards from the bottom of the screen, and you can pop it with the pin by moving your hand around, right? So you can pop bubbles. That's that's what we're going to do. Basic, but like it's a nice translation of the hand into something else inside the world of a program. So let us begin. The first steps that we need to do are the classics. We need to start with a template project and give it the correct name, Bubble Popper, open it, give it a title in index.html, and commit it to our repository. Oh, it's been a while since I thought about my repository. let's see what it looks like. I might have to commit something or 37 things right now, working on examples. This is in this repository is where I do a lot of my work on the examples that I use in this course. So that's what I'm just committing there. So let us begin properly. So we go to our repository. I've got a copy of the template project just sitting right here. So I'm going to copy that and I'm going to put it in activities. And I'm going to rename it to Bubble Popper. And I am going to drag it into Atom. Where's Atom? There. Okay. I don't really care about that right now. Thanks for making me look bad, GitHub Desktop. So the other thing I said I wanted to do is I wanted to give it a name in index.html so that rather than being called change this title in index.html, it is called Bubble Popper. Okay. And then if I go and open the script, I am ready to bubble pop. I guess I'll very quickly do just a couple of things in here just so that I feel like a professional. I'm just going to write pop bubbles with your index finger as a pin. I know that that's what it's going to be. It's not going to have a preloader, so we won't worry about that. And off we go. So what is our plan? It's a 4-part story here. And this kind of structure is pretty common, I think, for working with these sorts of libraries like ML5. Is the first thing you really want to do is get that basic framework functioning. And that means that we want hand pose to be loaded and recognizing hands, because that's really where it all begins, I think. That's how we're going to control this program, so that's like a good place to begin. So we'll do that. Then we will use the data coming in from hand pose to actually draw a pin on the canvas where the user's index finger is. Because we're not going to be able to see the user. We're not going to show the webcam. We're just going to show like a blank world with a floating magical pin in it representing the user's index finger. Then we'll add our bubble so that we've got the 2 elements that we need to exist in this simulation. And then finally we'll add the interaction with them to make it pop. None of these steps is going to be super duper complicated, but as you probably already know, having learned some things about ML5.js and hand pose, really a lot of the stuff comes in around working with the data that comes out of hand pose, right? And so this is a chance to just have a bit of practice with that. So let's do step 1. So we're going to get hand pose working. Generally speaking, when you're doing this, you're more likely that you're going to start with a pre-existing example and kind of edit from that a basic kind of example, or you're going to use a framework maybe that I've provided as part of these course materials. But for now, let's just go through the steps one last time. So the very first thing that we need to do, of course, is we need the script tag to include ML5 in our project. So I'm going to go to Getting Started and find the script tag as instructed. No justice, no peace. I agree to that. Click on Getting Started up here. Wait. The internet has to do things, you know, it's a busy thing. It's a really busy thing this morning, apparently. Waiting. There we go. Okay, well, there's the script tag right there. So I copy that, and then I head over to Atom, and I put that into my index.html above my script, right? Perfect. So now I've got ML5. Simple as that. I always enjoy how easy that is, right? Like by pasting in this one line into my HTML, I magically access all of these superpowers out on the internet. Okay, so I can close that again. Include the script tag in index.html. So that's done. The next thing that we want to do is think about, well, what input is ML5 going to have? And that's going to be the webcam. So we need to do webcam stuff, and we'll do that in the setup function of our program because we want to just start the webcam at the beginning of the program just the one time, right? So it's a setup kind of a task. So first of all, let's create a canvas. That's a good idea. We need a canvas because we're going to display things. So let's say create canvas. I've suggested 640 by 480 as a possible size there. That's a good classic size. That actually used to be the case that computers, this was the maximum resolution a long time ago, but it used to be. Declare a global video variable. This is language that maybe hasn't appeared so much in previous activities. When we say a global variable, what we mean is that variable needs to be up the top of the program, outside all of the functions. So we're going to create a global variable by putting it up here, let video. And maybe I'll just explicitly say undefined because it hasn't been assigned anything yet. And that's going to store the user's webcam. Okay. So we've declared our variable. Now we need to get the video in there, and we do that with this create capture function from P5.js. If you go and look at the P5.js reference, you can look that up. There's create capture, and you can see that the basic usage is kind of like this. Their variable is called capture instead of video. That's fine. You can see a very typical pattern here. You create the capture and then you immediately hide it after that. The reason that you hide it is that it's an HTML element that's being created to capture the webcam. And most of the time, if your program is just a P5 program using the canvas, you don't want another HTML element on your web page. You just want the canvas. So you hide that element. So these two steps often go together. Creates a new HTML5. That is not very good documentation. Okay, so let's do that. So we know that we want to do create capture with video, and we know actually that we want to assign that into our variable, right? So that's access the user's webcam. Access user's webcam. And then we know that we want to hide it. I think that's also in our instructions over here. Hide the video element so it doesn't display on the page. That's just to avoid it not looking so nice. So video.hide is the instruction for that. We saw that video.hide over here, right? So capture.hide because that's their variable name. That's how we hide the element on the web page. Okay, and it's as simple as that. Now the user's webcam has been accessed by our program, and all going to plan, I think as it says here. We should be asked for permission to use the webcam, and then we should see that light turn on. So let's run the program since we've done one step so far. Start server. And there you go. So this website wants to use your camera. Allow. And you can't see my little green light turn on, but it did. And you can see the little recording light here at the top that tells you that it's using either the camera or the microphone. We know that it's using the camera. So step one is going well. Now we get into the real business, which is that we want to use hand pose. Now, using hand pose at this point is really just formulaic, right? We just want to create the model and start listening for predictions, and that's the very, very typical structure that we use with these machine learning features, because what they tend to do is make predictions. We want to create the feature and then start asking it to give us the data that it can tell us about. So again, we want a global variable that we're going to use to store the hand pose model. I think it's a good idea to name this variable after the actual model that you're using, so hand pose, just because that gives you that extra little bit of information, right, that you can use to understand the program. So we're going to say let hand pose is undefined. And then we're going to create it down here in setup, right? So in setup, assign a new hand pose model to the hand pose variable with 3 arguments. So this relies on us remembering how you create a hand pose feature. If you don't remember, you go back to ML5JS, no justice, no peace. You go to the reference, and you scroll down until you find hand pose in the reference, which is just here. And then, I mean, you can either look at the quick start thing here. In this instance, it's not as useful because we're going to do a little bit extra. Or you go down here and you look at the initialized discussion in the actual API reference, and you can see that you assign the result of this ml5.handpose thing, and you provide it with the video input, which we know is our video variable, an options object, which we are going to use, and the callback, the function that it's going to call when the model is loaded. So we can see the syntax here, right? So we can actually just copy this if we want to. I'm just going to copy that, and I'm going to head back here, and I know that I'm going to load the hand pose model, and I know that I'm going to assign this into hand pose, and I'm going to assign this. Now I'm going to have to fill these out, right? Because right now these are not going to work. I do know that the thing that's going to have the video in it is the variable called video that I created right here. The options object is going to be, it's optional. The options object is optional. You could put an empty object here with no options, or as we saw in the other example, you can actually just put nothing there. But in this instance, we do want an option, and it's actually discussed in the activity. And that is that we want to use the flip horizontal property. I'm going to set it to true so that the video is mirroring. That's going to be important. So we want a flip horizontal property. So we write flip horizontal inside the curly brackets. That's the name of the property. We want to set it to true, so we write true there. And if I save, it's auto formatting so that that's on a new line. And then the final thing we need to do is we want a function to call when the model is loaded. And what do we say here? We want an anonymous function that does nothing. If you want, you could have a console.log that just says model loaded or something like that. Let's do that. So an anonymous function here for the callback. To define an anonymous function, we write function, and then the parentheses, and then the curly brackets, and then in there we can do nothing, or we can say console.log model loaded, like that. So now we've created our hand pose model with the webcam input that we just created. We're flipping the video feed horizontally so that when we do detection, it's more like a mirror instead of being reversed. And we provided it with this function here that's going to be called when the model is actually loaded, and it's just going to say model loaded, so it doesn't really do anything particularly. If we go and look at our program now, and we look in the JavaScript console, so now you'll probably notice the program might kind of take a minute to respond, like my JavaScript console took a second there to come up, and that's because it was in the middle of loading the ML5 model, which is a big task. But you can see here now it says model loaded in the console because the model is ready for use. I might leave my console up now. Okay, so the model is loaded. The final other thing we want to do is we want to actually process the data. To do that, we're going to have this common pattern that we're seeing in ML5, which is we have a global variable. We're going to call it predictions, which is going to be an array, and it will start out empty, and this is where we're going to store the data that handpose spits out when it makes predictions. So a global predictions variable with an empty array. So let's add that up here. The current set of predictions is what this is going to be storing, and it's going to be an empty array because there are no predictions right now. We make it an empty array instead of undefined because we know it is going to be an array in the future, and so this is a good way to symbolize that there are no predictions right now as an empty array, because it tells us the kind of thing that's going to be in there. And then in setup, we're going to do the fairly typical use of handpose. We're going to use the on method of handpose to create a listener that's going to listen for the predict event, and when that predict event occurs, we're going to provide it with an anonymous function that will deal with the data. And what is it going to do? It's going to put the results of that prediction into the predictions array. Now again, if we're forgetting what that looks like, we can go back to the documentation. We can scroll down past the properties into the methods. We don't want predict because we want to do constant continuous prediction, so we won't use the predict method. We want to use the on method, which is right here, right? And here's the basic idea of what we're doing, right? So handpose.on predict is the event name. That's the thing that we're going to be paying attention to. And then we've got our function here. This is an arrow function. You've seen some of these by now, so they're hopefully less alarming. But this is basically an anonymous function that takes a results parameter and does a console.log inside the function. So this is the idea of what we want. We could copy it, but I'm going to type it out because I don't want this arrow function. I want to use this more standard anonymous function here. So after we've loaded, we want to listen for data, or let's say listen for predictions. And to do that, we know now that we say handpose.on. That's the method that allows us to listen to things. The event that we want to listen to is called predict, so we put that in a string. And what do we want to do when a predict event happens? We want there to be a function that has one parameter, which we're going to call results. And what does it do? Well, it's going to do two things according to the activity. One of those things was just to print it out so that we can actually see what the results are. The other thing that we were going to do is we're going to assign the results into our predictions array. So predictions is assigned results. That way, because results is really only available inside this anonymous function, so we wouldn't be able to use those results anywhere else in the program, by assigning them into the predictions array, because the predictions array is a global variable, it's visible everywhere in the program, and this is what allows us to use the results from each prediction anywhere that we want to in our program. So really what this on method is doing is keeping that predictions array up to date with the latest results. It's like Twitter or something. Not really. Okay. So that's done. So if we run the program, in the JavaScript console, because we added that, that console.log of the results here, if it sees a hand, we should see the results appear in the console. So let's see if that's true. So we can see over here some empty, mostly empty arrays. We are seeing the occasional array you can see with the extra curly brackets in it. That's it recognizing a hand. If I hold up my hand now, now you can see that the results are all coming in with actual somethings in them. And if I take away my hand, now it's back to empty arrays, right? So if we expand one of those arrays and we look at the first element in the array, it's got the hopefully at least a little familiar set of properties that handpose provides. So there's the landmarks, which is just a giant array of all of the coordinates that that handpose recognizes in a numeric order. We've got the hand and view confidence, so it's 0.9999% sure. That's pretty great. And the bounding box, top left, bottom right. And then the annotations, which is the one that I tend to favor using because it's got like some actual semantics. Like this is telling us where the index finger is, this is telling us where the pinky is, etc. Pinky. I call that little finger. I guess they call it pinky. Okay, so that's working, right? This means that it is definitely recognizing hands, and data is being put into our predictions array. So we're in a good position right now. So that's it, and that's it in terms of like getting hand pose to say stuff, like we're done at that point with hand pose. It's now just the data is available, and it's what do we want to do with that data? So again, like this is a very small program, isn't it? Like you can fit it all just on the screen with comments even. So we just have some variables, we get the webcam going, we get hand pose going, and then we listen to the hand pose results. And that's it. That's all it takes to have hand pose data coming into our program. Everything that remains is about what do you want to do with that data. And the world, the world is our oyster, etc. But let's do something simple. So let's turn this index finger into a pin. Let's do this idea, right? So to make the user's index finger into a pin, really what we need is we're going to draw a line. So from the base of their index finger to the tip of their index finger, that's going to be the body of the pin. We'll draw a little kind of pin head at the base of their index finger so it looks more like a pin. It's a little bit more recognizable. And to do that, we need to interface with the hand pose data, right? We need it to tell us where is the base of the index finger and where is the tip of the index finger on the canvas right now. We need that information in order to draw the pin. Okay, so let us do that. Let's work in draw, because now we're going to be we want to draw this pin every frame. So let's fill the background first so that we've got a background. So now we're heading down to draw, background of black. I think that's a reasonable color. And now we want to do a few things. And the first thing we want to do is we want to make sure before we try and draw our pin finger, we want to make sure that there is a prediction of where the hand is to use. Because otherwise we shouldn't be drawing the pin if hand pose doesn't think that there is a hand there, and therefore an index finger there. So we need to make sure that there's something in the predictions array. The way that we can do that is we can check, is its length greater than 0? So we want an if statement to do that, right? If predictions.length is greater than 0, then we can work on the assumption that there is actually a prediction inside that array that we can therefore work with. So that guarantees that there's a prediction, that there is a hand. And now we want to basically pull out the tip of the index finger and the base of the index finger into XY coordinates. And we know that that data is in there, and it's just a matter of kind of getting to it. So how are we going to get to that data? Let's take the step of saying let hand is assigned predictions 0. We know that hand pose only predicts a single hand. So that single hand, now that we know that there is a hand, is going to be at position 0. We also know, thanks to the annotations, that we can get out the information about the overall index finger, which I'm just going to call index, by going to hand, which is the data about the hand, dot annotations, dot index finger. That's what it is. That's it. Sorry. Yeah, that's where all of the information about the index finger is. How do we know that? Well, we can either read the documentation. We can go back to hand pose. We can scroll up to where it gives us some information. This is slightly not helpful because it doesn't tell us all of the things, but we know that we've got the overall hand information is this, then the annotations is within that, and then there's all of these finger names within that. We can also inspect the data that's coming into the bubble popper. I guess I've broken my program now. Hold on, let me save that. Okay. So we'll wait until the model loads and we'll get a hand readout, and then we can like specifically look at the data again quickly. It's just I do this sort of thing all the time just to remind myself of what's going on, right? Okay, so there's some data. So let's take a look at it. So this hand and view confidence is great. In annotation, so we want to drill through, right? So here's the hand at position 0. Here's the annotations. And then this confirms, yes, that property is called index finger. That's got the data about the index finger. And also, and that's all that we want, right? We don't want the thumb. What was I thinking? I was thinking about thumbs. We just want the index finger. And then we know that the index finger has got these 4 elements in it. It's an array with 4 elements. One of these is the tip, and one of these is the base. We know, or I know, and maybe you remember, that 0 is the base. So these are the coordinates of the base here, and 3 is the tip. So 3 is the tip. So let's work with that. So hand is at prediction 0, the first element in the predictions array. The index finger information is at hand.annotations.indexFinger. And then we can say, what are we going to call this? Tip x is assigned the index finger array I'm just going to call this tip. We'll do this step by step. So the tip is at index 3, and the base is at index 0. And again, so now tip and base have got those arrays of 3 elements that give the x and the y and the z. You can see it takes some time to get into this, right? So tip x is at tip 0. I'm just going to be really explicit about this. You could just use tip 0 and know that it means x, but I kind of like to be explicit here. And tip y is at the tip array 1. And then same thing for base. Base x is at, base 0, and the base y is at base 1. That's quite a lot of work. You don't have to do all of this work. It depends on what level of abstraction you feel comfortable with. I'm doing this just so that it's super clear that by the end of this I have the literal x and y of the tip and the literal x and y of the base in named variables. That's just a choice that I'm making. Okay, back to here. So we've done these things. So display a line between those 2 coordinates. That's the pin. So that we can do, right? We know how to draw a line. So let's do a push and a pop. And let's set no fill. I mean, it's a line, so I guess that doesn't really matter, does it? And stroke of white. I feel like pins are white. They're not, but this one is. And then we're going to draw a line from tip. Well, let's start from the base. That makes more sense to me. Base x, base y is the first point, and it's going to be drawn to tip x, tip y. And maybe I want to set the stroke weight a little bit as well. I'm going to set it to 5. No, that seems silly. 2. Just so it's a little bit clearer on the screen. So that gives me the pin. We can test this now because we've pulled out the data about where the index finger is, and we've drawn a line across the index finger from base to tip. So if I hold up my hand, yeah, there it is. So that's orienting with where it sees my index finger as being, right? I'm waggling my index finger right now. Boop, 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 boop. So that works. It makes that sound as well for some reason. To make it look even more like a pin, let's draw a circle at the base, just so that it's clearer really which end the tip is. So we're going to add another visual thing. You can already probably tell that we should be breaking this down into some functions. But just because I'm just doing this as an activity, we can tidy it up later. You can tidy it up later. So we're going to set we're going to have no stroke this time. We're going to set a fill. I'm going to make it red, like a classic push pin. And then I'm going to draw an ellipse at base x, base y. That's where it's going to be centered. And I'm going to make it not too big, 20 pixels, let's say. And what that will do for us, if we head back, is it'll just look more like a pin. I don't know, not much more than that. So if I hold my hand up, once the model loads, right, because we're waiting for the model to load, now this looks more like a pin. Even like it looks kind of 3D. It's not 3D. Well, it could be 3D, but it is not being 3D right now. That's just me moving my index finger to point at the camera. But quite effective. So that's working really well. Yeah, okay, anyway, don't get too excited, Pippin. So now we've got a program that displays a pin. We're really just about there. So let's add something for us to use this pin on, which is going to be a bubble, and we're going to pop it with the pin. So again, we need an undefined global variable that's going to store the bubble in it so that we can manipulate the bubble. So we need to go back to the top of our program, and we're going to say the bubble, and that's going to be undefined. I'm making it undefined because I want to define it in setup using the width and height of the canvas. So in setup, we're going to create an object literal. That's one of those objects that's inside curly brackets. And we're going to give it an XY size, a VX, and a VY. It's going to start in a random position, a random X position at the bottom of the canvas. That's why I need to know about width and height. Size doesn't matter, you can choose. Size doesn't matter, you can choose. And it's going to have no X velocity, because it's not going to move on X, and a negative Y velocity so that it can go upwards. So basically, a bubble starts at the bottom and goes up. So our bubble. So bubble is assigned a JavaScript literal, which is this kind of literal object. It's going to have an X The X is going to be a random position on the canvas, so random width for that. The Y is going to be at the bottom of the canvas, and we know that the bottom of the canvas is at the height. The size is up to us. I'm going to make it, goodness me, what am I going to make it? 100. And then it needs a Vx. I'm making that 0. I have a Vx even though it doesn't move on that, just because, you know, it's weird to give something movement properties in only one dimension to me. And a negative y velocity will mean that it will move upwards once I add the movement code, right? Like just adding these two things, as you know, doesn't mean that it will move. I need to actually add some movement code. Okay. Then we can draw the bubble and move the bubble. Or actually move the bubble and draw the bubble. So in draw, after the predictions check, so we don't want to be inside the predictions because the bubble is independent of the hand pose stuff, right? It always exists whether or not there's a hand. So we want to do some classic steps, right? We want to, first of all, let's change its position based on its velocity. So let's do that first. So in draw, so all of this stuff is in hand pose, right? This is only happening if there is a hand, so I want to go after that because the bubble doesn't depend on that. And I want to change its position by its velocity by adding its velocity to its position. By adding the Vx to the x and the Vy to the y. So that's moving the bubble. I should have done some commenting up here, but I forgot to. I was too excited. Pin body. Pin head. There. Now I feel slightly better. So that moves the bubble. Then we wanted to write a statement, an if statement that's going to check, did it go off the top of the canvas? And if so, move it back to the bottom in a new random x position. So a way of resetting it, right? So if bubble.y is less than 0, that means it's gone off the top. Then we want bubble.x to be random, so a random width. And bubble.y should go back down to the bottom. So really just what we started it with, right? Is just resetting it to the bottom in a random location. Good. And then finally, we want to actually display the bubble on the canvas using its properties. So let's do a push and a pop. And then let's set a fill of, I don't know, what color should this bubble be? That. I don't know what that is. And no stroke. And then we'll draw an ellipse at bubble.x, bubble.y, bubble.size. Bam. That should be enough. Let's go look. Oh. I don't know what's happening. Why is this not doing anything? Oh, there it is. Oh, again, like this is it's very disorienting when you're working with these. Oh, and there's the pin as well. Very disorienting. I'm gonna poke you, but it doesn't do anything yet. It's disorienting with ML5 because the program, it does lurch into life, right? Because the model is quite heavy duty to load. So there's our bubble floating upwards. It's quite slow. And when it gets to the top, it's going to wrap back around to the bottom. Perfect. Final thing is we want to pop the bubble. So we want an interaction. We know about checking whether there's an overlap with a circle. So basically, if the tip of the pin, which is the pointy bit, if that's inside the bubble, and we know that if its distance is less than half the size of the bubble, then the bubble should pop and reset. So first thing we do is we calculate the distance of the tip of the index finger to the center of the bubble. Now, importantly, as it says here, we have to do that inside the predictions checking, right? Because we can't do it outside because we don't know if there's an index finger. We can only check this if there is an index finger. So let's do that. Where should we do that? Let's just do it here. Check bubble popping. So first of all, the distance. So let the distance be dist tip x, tip y, which we know is the tip of the index finger, bubble x, bubble y, which is the position of the bubble currently. So what's that distance? And then what do we want to do? We want to check if that is inside the bubble. So is it less than half the bubble size? And if it is, then reset the bubble to the bottom of the canvas. So if the distance is less than half the bubble's size divided by 2, that means the tip is inside the bubble and it should pop. and we should reset it. We've already got code to reset it down here, so I'm just going to copy this. Clearly that means that resetting should be a function, because I just copied and pasted some literal code. But that's it, right? That's all it takes for the index the index finger pin to interact with the bubble. So let's check that out. So we wait for this to begin. There we go. Okay, and then I get my pin. Where's my pin? Where's my pin? Give me my pin. Oh, it's still loading. We can do this. You can do this program. I'm waiting. I believe in you. This is why you need a loading screen. Okay, so there's my pin. And I go over here. Pop. And it pops and it goes down to the bottom. Pop. I don't know why it makes that sound. Pop. Oh, goodness, it won't stop. Pop. And so forth, right? So we've got the most basic little bubble popping simulation going on. But it's kind of miraculous because it's like literally my hand, my index finger is being transformed into a magical pin into the program, and it's popping bubbles inside the program. My hand is interacting with the program. It's pretty amazing, right? So there's plenty more to do. There's a lot of breaking into functions, I think, that would make a lot of sense. You could represent the pin as an object instead of just as a set of variables that we work out. We could add a loading screen, etc. But that's the basic idea, right? We're using our hand to interact with our program. So hopefully that's just the beginning, and you can like go from there to like make hand interactive programs for the rest of your life. And I hope that you make a fortune doing so. All right, that's it. That's the bubble popper activity. Hope you enjoyed it, and I hope you make something amazing going on from here. Bye.